This is a supplementary video for our work titled Design, Implementation and Validation of an Ungrounded Visuo-Tactile Haptic Interface for Robotic Teleoperation in High-Risk Steel Production. A steel mill is one of the most extreme industrial sites due to the hot molten iron. In the iron-making process, lump iron is generated from molten iron erupted from the tap hole, and it can block the flow of molten iron. Thus, removal of adhered lump iron must be performed continuously. Currently, the removal of lump iron is performed manually by trained workers using long sticks. However, working environment is extremely dangerous due to splashed molten iron. Thus, we aim to develop a robotic teleoperation system specifically for the lump iron removal task. In particular, we focused on the development of haptic command interface for safe and intuitive teleoperation. We developed an ungrounded haptic interface called POstick-VF, which offers an extensive workspace combined with Visuo-Tactile feedback. POstick-VF provides an unlimited workspace with a wireless 6DOF pose tracker. Visual feedback is provided based on the magnitude of the joint angle error between the command and the robot, which indicates interaction force of the robot. Additionally, vibrotactile feedback is provided with both spatial and temporal modulation. To achieve this, 4 vibration motors are mounted in line to generate a vibration flow. We integrated POstick-VF with an on-site hydraulic robot manipulator, and this is the entire control structure. Operators manipulate the remote robot using POstick-VF while receiving Visuo-Tactile feedback based on the joint angle error between the command and the robot. This is because the remote robot lacks force-torque measurement sensors. Operators also receive 3D stereoscopic visual feedback captured by an RGBD camera mounted on the robot base. Finally, on-site validation was conducted to evaluate the performance of POstick-VF. This is the experiment setup of the on-site validation. In a test bed similar to the environment near a furnace tap hole, a light wood block and a heavy steel block were placed on the sand to evaluate various manipulation skills using POstick-VF. Operators can perform intuitive and accurate teleoperation using POstick-VF. First, they have to access and poke the tool underneath the surface of the lump model. At this moment, multi-degrees of freedom motion requiring simultaneous control of position and rotation was performed. Finally, the lump model was removed by flipping the object. Furthermore, operators can perform comprehensive manipulation using POstick-VF. They can even perform balance control of light block. Moreover, poking the tool underneath the surface of the lump model through rocking in the roll axis is identical skill used by trained worker during lump iron removal. Each subtask is performed seamlessly in continuous manner, which was not possible with a conventional joystick controller. In conclusion, we developed ungrounded haptic interface for robotic teleoperation of high-risk steel production. Then on-site validation is conducted using POstick-VF with hydraulic robot manipulator to evaluate the performance of POstick-VF. As a result, intuitive and accurate manipulations are achieved using POstick-VF, which were not possible with a joystick. This is the end of our supplementary video. Thank you for watching.